From the Plugins menu, select the AM Modeler Show Hide option so that the AM Modeler option will be added to the model tree. By clicking on AM Model and selecting Create AM Model, a window will be open for us. The type of our analysis is thermal structural. We are simulating a process that is already included in Abaqus simulation conditions and is not custom. The model is a sequential type, first thermal and then structural. Heat transfer and static general steps are automatically detected. The models are selected based on the steps. The Model 1 is for thermal and Model 2 for structural. This window indicates that if you click OK, you cannot change the type of the analysis and the type of process and your models. Expand the AM Model 1 and you see three main sections of AM Modeler: Data Setup, Model Setup, and Simulation Setup. We open the table type from the Data Setup and then enter the parameter table. By default, in this version of AM Modeler, there are different types of table parameters. And as explained in the AM Modeler plain tutorial, a number of them are used for each problem. But how do we know which table parameter to use for each problem? In one of the examples in the document, a list is provided that will be useful. Go to this path, Abaqus Example Problems, Additive Manufacturing Process Simulation Sequential Thermomechanical Analysis of Laser Powder Bed Fusion. Open this input file. See, these are the list of different methods and the parameter table needed for each one. But let's see the required parameter table for the thermomechanical analysis using trajectory-based method. Well, for material deposition in this method, ABQ material deposition is required. Because we use the roller, we don't need the bead mode. And advanced and variable bead modes are optional for us. For the laser, we use ABQ-AM moving heat source and ABQ-AM absorption. Because we use concentrated energy distribution, we do not need uniform and Goldak modes. And as before, advanced and variable beam modes are optional for us. We must keep the necessary items and we can delete or keep the items that are not used. You see ABQ-AM moving heat source, one of the required parameter tables in this simulation. It has two rows. The first row is related to the event series of laser motion. And the second is related to energy distribution, which can be concentrated, uniform, or Goldak. The second parameter, ABQ-AM material deposition, has two rows. The first row of the event series is related to material deposition, and the second row specifies the type of deposition process with roller or bead. Here we have two event series types. ABQ material deposition has 5 fields. 4 of them are related to time and location, and the last field shows whether the roller is on or off. ABQ power magnitude has 5 fields as well. The 5th field is related to the magnitude of laser beam power. These two event series types are used. Of course, you can create as many as you like. From the event series option, create the first event series. You see the fields that must be completed. But since we want to attach the data as a file, we tick the option From File and browse the file we want to attach. We select the laser's event series file in INP format. Usually attaching the file is for a case where the data volume is more than 1 megabyte. We change the event series type to ABQ-AM power magnitude because we attached the laser event series file. Let's look at the file. You can see the data in 5 columns corresponding to 5 fields. As we said in the PowerPoint, we use these data to find the laser path and laser speed in the software. The first column indicates time. The next 3 are for the coordinates of the laser beam in this time. And the last column determines the laser power magnitude. The units of the coordinates are based on the millimeter. And the unit of the power is watt. For example, at the time 0.4 seconds, the laser beam is at this point and its power is 100 watts. I know what you're thinking. I said watt, but this one has another 3 zeros. As you know, the unit of watt is Newton meter per second. Since we're using millimeters, then we have to multiply it by 1000. It's just a simple unit conversion, and now you know the story behind those 3 zeros. As for the laser speed, we've talked about it enough in the PowerPoint. About the laser path, however, you will learn more about it soon enough.